All right, we're going to do 33 to 36. We're going to use Pascal's triangle. These are only squared, so we usually use Pascal's triangle when you have to expand something with a higher exponent, but the structure is going to be the same. So Pascal's triangle, I'm going to do it above 33 just to remind you. It starts with a 1, and there's your first row. There you are. Then the next row starts with a 1 and ends with a 1. And the next row starts with a 1, ends with a 1. And then you add the numbers in the middle. And if you had to go to more rows, you would. So you start with a 1, end with a 1, and you add the numbers there. That's 3. Add the numbers there. That's 3. And you'd follow that pattern all the way down. So if you have two terms that are being squared, a binomial, then this is the row that you would use. And the second number tells you in terms of the exponent matching. So that second number matches in terms of what we're doing. So when I look, oh, I did that way high. So when I look here, I need to know which terms there are and what I'm going to do. So one term is 3k, and the other term is 2. And then the pattern we're using is 1, 2, 1 with exponents. So we start with a 1. The first term is 3k, and that gets the full exponent. Well, 2 gets 0, the lowest exponent. Those two always have to add up to what exponent there is. And then I go plus, and I do the next number in the triangle, which is 2 in that row. And again, it's 3k, but this time we're going to go down 1, so now it's 1. And then 2 is going to go up 1, so now it's 1. So it's going to go in the other direction. Then the last one in the row is 1. And again, we have 3k, and it's now going to be, as it goes from 2 to 1 to 0, well, 2 goes from 0 to 1. Now it has the most powerful exponent at 2. And then we simplify it and have our answer. So 2 to the exponent 0 is 1. So really it's just 1 times 1, and then we just need to do this, which is 9k squared. There's our first term. The middle term, to the exponent 1, doesn't change these numbers. So I'm going to go 2 times 3 times 2. That's 12, and so it's 12k. And then the last one, again, 3k to the 0 is just 1. So it's 1 times 1, and 2 squared is 4. So 1 times 1 times 4, and you have an answer. So there's another way to expand it. So we're going to do the same thing for 34. Same numbers. We're going to start with 1. The first term is 8r, and it's going to be squared. Well, the last term to the 0. The next number is 2 in Pascal's triangle. Again, it's 8r to the 1 and 4 to the 1. And then 1, and then it's 8r to the 0 and 4 to the 2. So see a structure, see a pattern, and follow it. Again, 4 to the 0 is 1. So it's really 1 times 1 times this. So that's 64r squared. Here the exponent 1 just means you multiply. So 2 times 8 times 4, that's 64. And that's r. Again, anything to the exponent 0 is 1. So it's just 4 squared, which is 16. All right, number 34, practicing the structure of Pascal's triangle. So we start with a 1, 6x squared, and then 6 to the 0, then 2, 6x to the 1, 6 to the 1, and then 1 again, 6x to the 0, and 6 to the 2. And see that structure and pattern, and then multiply it out. So this is going to be 36x squared. 6 times 6 times 2, 64, right? X, and then 36. Did you right? Sorry, 630 is 70. What is it? 6 times 6 is 36, and double it, 72. Haha. There we go. All right, last one here. Structure 1, and it's 5x squared and negative 4 to the 0. Then 2, 5x to the 1, negative 4 to the 1. And then 1 again, and it's 5x to the 0 and negative 4 to the 2. So there's the structure of it. This is 25x squared. Multiply this out, and it's negative 40x. And this is 1, so it's just plus 16. All right, different way. Pascal's triangle. Great job doing your homework. I'm proud of you. Till I see you in class, Mr. G Math, over and out.